Hello, everybody. So today we are doing something brand new for the first time. Hopefully you have made it to our Echo Classroom. You have checked in on the attendance for today. Please make sure you do that. And what I need you to do is click on the Functions Notes template. When you open that, it will ask you to make a copy. So please make a copy of that. And then let me try, it's not shifting. There we go. All right, so I'm going to make a copy. And when I get into the copy of this, I'm going to come up here to the title. I'm going to delete this beginning stuff, and I'm going to call this notes. I'm calling it notes because it's super important that I know that I can find my notes, and then I know that these are the notes for functions. Hopefully by now you've created a folder in your Google Drive that's math. So I would go ahead and I would put this in my math folder. I would scroll down and I would say, hey, I want to save this to math work. If you don't have a folder that's just for Bell 4, Bell 3, Bell 2, whatever Bell math you have, you can click this create new folder, title it, and then you would move it here. If you do have a folder for your math work, scroll down and go ahead and say, hey, I'm going to click this in my math work. Now that the ticky-tack stuff is done, here's where the notes start. I'm not going to leave pauses in here for you to type and work, so please make sure that you go ahead and just pause this video when you need to get stuff copied. But basically, if I have it written down on my copy, you should have it written down on your digital version as well. Our objective for this lesson is I can describe a function as a rule. Now, in thinking about functions, the way we're going to start thinking about this is by considering a pop machine. We got a Coke machine, Coke, Pepsi, whatever. With this pop machine, there's a relationship that exists. There's a button I push, which I'm going to call the input, and then something comes out, which is called the output. So I'm heading my table that way. If I go up to the Coke machine, I put my money in and I hit the button for Coke, I would expect a Coke to come out. If I go up and I hit the button for Sprite, I'm going to expect a Sprite to come out. If I go up and I hit the button for a water, I would expect a water to come out. If I go up and I hit the button again for Coke, I should have a Coke come out because I hit Coke up here, I should get Coke down here as well. Now, something to note, we're using pop names. In the real world of mathematics, these are going to be numbers and they don't have to be exactly the same. For example, this Coke machine maybe has more than one button that says Coke. So I might hit Coke button 1 and get a Coke. I might have another button for Coke that's separate and I still might get a Coke. So as long as what I input is my expected output, I'm good. Now, the way I kind of introduce this thinking is let's go on a field trip. Let's pretend. We're on the bus ride to the field trip and our bus breaks down in the middle of nowhere. So we're in the middle of a desert, not sure what's happening. It's super hot because the bus doesn't have air conditioning. We happen to see a janky looking Coke machine. So we're going to test it out. First student walks over and says, I'm gonna see if it works. Puts money in, hits the button for Coke. The Coke pops out. Gets all excited, runs back to the bus. Hey, y'all, the Coke machine works. It works. Put money in, got my Coke. Hit Coke, got my Coke. Second student goes up. Hits the button for Coke, only this time a Sprite comes out. Well, that's not normal. If I hit a button for Coke, I should get a button for Sprite. Third person goes up, hits the water button. Water comes out. Fourth person goes up, hits the Coke number 2 button, and this time gets a Coke. Oops. Oh my goodness. All right. So Is it safe to say that there's something wrong with this pop machine? Probably is, because I hit the Coke button and I got two different answers. So let's come down here. Here's where we get into the math vocabulary about it. A relationship where one thing or that first thing is an input, so it's the first thing the button we were pushing, depends on another or our output, is called a function. Yes, you should be typing these into your document. When it's not a function, it's called a relation. Now, in a function, here's the key here. Here's what I need you to remember. One input can only have one output. And the thing I need you to remember about this is that output in math terms doesn't have to be the exact same input. So it could be, you could hit button 1 and you could get a 4. They don't have to be the same number. But if I hit button 1 and I get a 4 is the only thing I can ever hit when I hit button 1. So let's come back up here. I'm going to label each of these tables so when I come back and use these as notes later, I can tell, hey, we called this one a function because each time I hit a button, I got the output I expected. We're going to call the other one a relation because it's not a function. I hit this Coke button and I got two different answers. So if I have to stop and jot, in your very own words, why was the first vending machine an example of a function? Well, I'm going to go ahead and say machine 1 was a function because when, or the output we pushed gave us only one, not output, Mrs. Lease, what's wrong with you? The input we pushed gave us only one output. All right, so the machine worked. For machine 2, one of the inputs had more than one output. In other words, the Coke button gave two different drinks. That machine's not working correctly. All right, so to review, a function is a relationship where each input has only one output. Now, looking down here, I have 4 tables. Each one of these tables is either a function or a relation. What I'm going to do is I'm going to go over and I'm going to label them. Table 1 would be considered a function because I hit 1, I get a 1. That 1 only has an output of 1. I hit a 4, I get a 3. Again, they don't have to be the same. Okay, so now we're getting into math speak. The 4, as long as every time I push a 4, I expect to get a 3, this would be a function. As long as every time I hit 5, I expect to get a 6, it's a function. Now that 6 or that 5 can only have a 6 as an answer. It'll make a little more sense when we look at this one. This one's a relation. It's a relation because I start off hitting 1 and I get a 7. I hit 2 and I get a 4. I hit 3 and I get a 13. So each of these first 3 has an output assigned to it. Now, if I come down here again and I hit the 1 again, I'm expecting a 7, but look what pops out. I get a 17. That's why this is not a function, because this input of 1 cannot have 2 different numbers come out for it. Look at the third table. The third table is a function. It's a function because each of these inputs is assigned to one number. Now, this fourth table has a slight problem, and it's a copy and paste issue that we had when we made this lab sheet. I need you to pretend there's a 5 in this box. This empty box right here actually has a 5 in it. For whatever reason, when we put it on this document, we can't get the 5 to show up. So we're going to know that it's a 5. And this one's called a relation. It's a relation because I hit 5 up here and I got a 9. But when I hit 5 down here, I got a different number. I should have gotten a 9, but I got a 7. All right. So now you can identify functions, on a graph as well. So this is how we identify functions in a table. Here's how we identify functions on a graph. We use what's called the vertical line test. What the vertical line test does is when you place a vertical line, which the vertical line goes up and down on a graph, and slide it. If the vertical line only crosses the graph line once at any place on the graph, it represents a function. Now, what that looks like is this. Hopefully it'll let me write. I've got this pen. A vertical line is up and down. So if I were to take this pen or this vertical line, no matter where I draw a straight up and down line on this graph, my blue line only crosses this black line once, no matter where I draw it. But look, if I come over to this one, if I draw a vertical line right here, it hits here and here. That means that this x value has more than one answer. That's not a function. So here's what happens. If I come down and let's give some numerical examples. Oh Lord, it's not centered. That bothers me. Sorry. Hang on just a second. I'm going to make this a numerical table, x and y. This is a function. So if I hit -1, there's a good chance, and I'm just making numbers up, that my y output would be -1. Now, if I have 0 right here on this graph, it looks like it's probably crossing a 0. Now, I don't know if this line is actually going through that or if it's 100% straight, but if I scroll down, let's say I got a 2. Well, what if my 2 was at a 3? That's still okay, as long as when I hit 2 again, I don't get a different number. So then I could say 5 might be at 6. Now, if I come over to this one, I need to give it numbers that don't match what a function would look like. So let's start with this one. We have x, we have y. If I go 0 in the origin right here, that's still 0. So that one's working out how we would expect. But if I move over a little bit and go to 1, notice if 1's right here, if I scroll up, I might be at +2. But then if I look back at the graph again, this 1, if it's at +2 here, it's probably at a -2 down here. I can't have, for this to be a function, this 1 can't have 2 different outputs, but that's what's happening on this graph. Okay? So the 3 might be, hey, if I go over to 3, it might be up at 5, which would mean the 3 down here would be at a negative number. So that's why this is not a function. So I can actually come in, let's see if it'll let me. Yep. I'm going to go ahead and say this one's a function. And then I'm going to label this one as a relation. All right, so why does the vertical line test work? Well, the vertical line test shows where on the graph an input has, let's change this. This vertical line test shows how many inputs, or how many outputs each input has. So if the graphed line crosses the vertical line more than once, so if the graph line crosses the vertical line more than once, it means that an input has more than one output. Okay. So now we have to go down and decide, are the following functions? Well, I have 4 ordered pairs. In my first ordered pair, I got a 1. So when I put in a 1, I get a 0. Does the 1 show up anymore as an input? Nope. So let's check the 3. Do I have a 3 anywhere else? Nope. How about an 18 or a 12? Nope. Because each of these only has one output, this is a function. Now don't get confused. All of these inputs all these outputs are 0. More than one output can go to an input. Let's go back up here. Remember, I had 2 Cokes that went to 2 different inputs. That's still a function as long as each of the inputs has only one output. So we're going to call this one a function. Now the next one, the vertical line test. If I draw a vertical line anywhere, pretend that's straight. Anywhere on this graph, no matter where I go, that graphed line, so this parabola right here, is only crossing my vertical line once. So we would call this a function. Now this one, if I draw a vertical line, notice it hits here and here. So that one is not a function. That one we would actually say is a relation. Here's another model. Here's my input. -1 goes to 4. Well, this -1 also goes to these 2, or we don't even have them pointing to anything. So this would be a relation. All right. Same thing here. -1 goes to the 4, but then it's also going somewhere else. This input can't go to more than one output. So this one would also be a relation. So I know this is still a little bit fuzzy for a lot of people. I don't want you to panic. We're going to talk some more about it. But please make sure you've got these notes completed. You'll submit them in the Echo Dropbox for this link because you are getting a grade on completing these notes. And then make sure you're asking questions in class if you're still confused about anything. We'll see you tomorrow. Have a great day.